Introduction to Lab 5, Auditory Localization. In this lab, we'll investigate several psychoacoustic phenomena involving the localization of sound. Part 1, Localization by Interaural Time Difference. Take a tube, fold it exactly in half, and carefully mark the center point. Put the ends of the tube in your ears and loop it behind you. One lab partner, the tapper, will tap on the center point of the tube with a pencil or a ruler. The listener should confirm that it sounds like the taps are centered. The tapper will continue tapping on the tube, slowly moving the tapping toward one end of the tube. The listener should say stop once it sounds like the position of the sound has moved away from the center. The tapper will measure the distance from the center of the tube and record that in the table. The tapper will then tap again, moving from the center to one end of the hose. The listener will make a detailed record of how the sound appeared to be moving. For example, was it inside or outside of your head, or both? Was it behind you or in front of you? Did it move left or right? Use this information for question 1. Repeat this with each lab partner. Once everyone is finished, complete the first table and go to Lab 5 in Blackboard and click on Click here to enter data. In the next window, click the link to go to the Google Sheet. Click the correct tab for your group. Add the names for each group member to the sheet. Enter the data from the bottom row of this table to row 3 of the online sheet. For the next part, put on the headphones supplied in the lab. In Blackboard, open Lab 5 and click on Left, Right, Center. If the sound is coming from the wrong side, switch your headphones around. If center is not in the center, adjust your balance control until it is centered. Get the polar graph for interaural time difference. Click on Sound Example 1. Adjust the volume to a comfortable level. Close your eyes and listen to the sound example, paying attention to where the sound appears to be coming from. Listen all the way through one or more times before marking anything. Then mark the apparent position of the sound on the polar graph. Mark the positions as announced, 0, 1, 2, 3, etc. If the sound is coming from in between your ears, inside your head, then the marks should be in the center of the graph. If it is coming from in front of you, it should go toward the top of the graph. The further away it sounds, the further the mark should be from the center. Each number represents the delay in tenths of a millisecond. At the bottom of the graph, indicate the value in tenths of a millisecond that you first heard a position shift. This should correspond to the first dot on the graph that is different from the initial sound. Part 2, Localization by Interaural Amplitude Difference. Get the polar graph for interaural amplitude difference. Click on Sound Example 2. Adjust the volume to a comfortable level. Just like before, listen to the sound examples and mark the positions on the graph. Each number here represents an amplitude difference in dBs. At the bottom of the graph, indicate the value in dBs that you first heard a position shift. This should correspond to the first dot on the graph that is different from the initial sound. Part 3, Binaural Recording Localization. Get the polar graph for binaural recording. Just as before, listen to the recording and mark the positions on the polar graph. Once you have finished marking all 3 graphs, fill in the tables on each graph. Then enter your data into the Google Sheet. After your lab group has entered all of its data, download your sheet as an Excel file. by going to File, Download As, Microsoft Excel. You'll now make a polar graph of each member's data for each of the 3 sound files, so there will be 3 graphs for each member. You will need to do this with the lab computer, as this will not work if you're using the Mac version of Excel. Download PolarPlotter 2013.xlam from Blackboard. In Excel, click File. At the bottom, click Options. On the left, click Add-ins. At the bottom, click Go. Make sure PolarPlot 2 is checked. If it's not in the list, click Browse. Find the PolarPlotter file, which is probably in Downloads, select it, and then click OK. Once PolarPlotter 2 is checked, click OK. In the Excel file, select your data. Click Insert. At the top right, click the menu item called Create. Uncheck Generate Angles. Click Options. Click Display Interval Axes, Labels, Grid Lines, Data Markers, and Axis. Click Data. Click the little box in the window, top left cell of output range. Click a cell to the right of the table, then click OK. Click OK. A graph should appear. Make sure that your graph looks like what you drew. Click on the graph, label it. For the time and amplitude graphs, include the time or dB values for the first position shift. Copy and paste the graph into your worksheet. These graphing instructions are available to download in Lab 5. Very important, you need to do all of this before you leave the lab so you can identify any typos. Typos will affect your group and the class average data. After the entire class has entered all their data, download the class results sheet as an Excel file. Make a polar graph of the class average data for each of the 3 sound files and label each graph.